Hello my dear students, welcome to my physics class. Our today's topic is elasticity. Elasticity. When a force is applied to a body, the volume or shape or both of the body may be changed, that is, a body may be deformed. The property of the material of the body by virtue of which the body regains its original shape and size after the deforming force is removed is called elasticity. That is, when we apply a force on a body, the shape, size and volume of the body is changed, and if we remove this force, then the body regains its original shape and size again. This property of the body is called elasticity. Few definitions related to elasticity. Perfectly elastic body. If a body recovers its original shape and size fully when deforming force is withdrawn, the body is called perfectly elastic body. If we apply force, the shape size of the body will be changed, but if we remove this force, if the body regains its original shape and size fully, completely, it can regain its original shape and size. That body is called perfectly elastic body. Elastic limit. The maximum value of the applied force up to which the body remains perfectly elastic, that is, the body returns to its original shape and size when the force is withdrawn, is called elastic limit. That is, we can apply up to a certain limit of force, that is, when this limit will cross, that is, if the applied force is more than the certain limit, then the elastic property of the body will be lost. Therefore, the body cannot regain its original shape and size after removing the deforming force. This limit, that is maximum value of the applied force up to which the body is perfectly elastic body, that maximum value of applied force is called elastic limit. Perfectly plastic body. If a body is deformed by applying an external force, and if the body retains its changed shape and size after the removal of the deforming force, the body is called perfectly plastic body. In this case, the body is deformed by applying external force, but when we will remove this deforming force, the body will retain its changed shape and size, that is, it cannot regain its original shape and size, that is, the deformation is permanent deformation. That body is called perfectly plastic body. Perfectly rigid body. The body whose shape and size is not changed by the application of external force of any magnitude is called perfectly rigid body. If we apply force of any magnitude, the shape and size of the body will not be changed. This type of body is known as perfectly rigid body. In practice, perfectly rigid body could not be found. Strain. The change in dimension per unit dimension of the body due to the application of external force is called strain. That is, the change in length per unit length or the change in volume per unit volume is called strain. It's a ratio of two same quantity, so it has no unit and dimension. That is, change in length per unit length. Therefore, it's a ratio of length. Change in volume per unit volume is the ratio of volume. Therefore, it will have no unit or dimension. Therefore, strain is a unitless quantity. Stress. When the shape, length or volume of a body changes due to an external applied force, due to the elasticity of the body, an opposing force arises within the body. The magnitude of the restoring force produced per unit area and perpendicular to the surface is called stress. That is, stress means restoring force per unit area. When a force is applied to a body to deform it, an opposing force produced which resists the deformation of the body. It is acts opposite to the applied force, and this restoring force is equal to the applied force. Stress is equal to opposing force divided by area. That means applied force divided by area. In this case, opposing force is equal to the applied force. Unit of stress is Newton per meter square. We know the unit of force is Newton and unit of area is meter square. Therefore, unit of stress is Newton per meter square. Braking force. The minimum applied force for which a body either breaks or snaps is called braking force. That means a body can tolerate up to a certain limit of force. If the magnitude of force crossed this limit, the body cannot tolerate this force. The body either breaks or snaps. The minimum applied force for which a body either breaks or snaps is called braking force. Braking stress. The minimum applied force per unit area perpendicular to the area for which a body either breaks or snaps is called braking force. That means braking force per unit area is known as braking stress. Braking stress is equal to braking force divided by area. Different types of strain and stress. Longitudinal strain and longitudinal stress. Longitudinal strain. If the length of the body changes due to the application of external force, the change in length per unit length of the body is called longitudinal strain. Here, due to the application of force, the length of this wire is increased. Here, initial length is L, and due to the application of force, its length is increased by del L. That is, after deformation, its length is L plus del L, and before deformation, its length is L. That is, the change in length per unit length is the longitudinal strain. Here, initial length of the wire is L. When a load is applied, then the length of the wire becomes L plus small l. That is, increase in length is small l. Here initial length is capital L and increased length is small l. That is, total length now L plus small l. Here length is increased by the application of this F is equal to mg force. That is, longitudinal strain is equal to small l divided by L. Longitudinal stress. For resisting the longitudinal strain, the restoring force produced per unit area and perpendicular to the surface is called longitudinal stress. That is, the stress produced for longitudinal strain is called longitudinal stress. Since the restraining force is equal to the applied force, longitudinal stress is equal to F divided by A. Here F is the force and A is the cross-sectional area of the wire. If the radius of the wire is R, the cross-sectional area will be A is equal to pi R square. Therefore, longitudinal stress is equal to mg divided by pi R square. Here force F is equal to mg and area is equal to pi R square. Here the cross-sectional area is equal to pi R square if the radius of the wire is R. Volume strain. If the volume of the body changes due to the application of external force, the change in volume per unit volume of the body is called volume or Bach strain. The volume strain is also known as Bach strain. Here the initial volume, by the application of force, the volume of the body is changed. The change in volume per unit volume is known as volume strain or Bach strain. Here del V amount of volume is decreased by application of force, external force. Here the volume of the body is V. Now if the external force is applied on this body, then its volume will be changed. Here the changed volume. Here V is the volume before applying force, and after applying force its volume is V minus small v. That is, change in volume is small v. Initial volume is capital V and decrease in volume or change in volume is small v. Now the new volume is V minus small v. Therefore, volume strain is equal to small v divided by capital V. Volume stress. For resisting the volume strain, the restoring force produced per unit area and perpendicular to the surface is called volume stress. That is, volume for resisting the volume strain, that is, due to the volume strain, stress produced is volume stress, and it is F divided by A. Shearing strain. Here in this block, a force is applied perpendicular to this surface, and here force is applied horizontally, that is, here a tangential force is applied on this surface, and here the force is applied perpendicular to the surface, that is, this is perpendicular force and here tangential force. For this perpendicular force, the body is compressed, and here due to this tangential force, the shape of the body is changed, but there is no change in volume, only the shape of the body is changed due to the tangential force on the upper surface. Here lower surface is fixed. This type of strain is known as shearing strain, that is, shape of the body will be changed, and this type of stress is known as shearing stress, that is, tangential force per unit area is the shearing stress, and this type of strain is shearing strain. Here a rectangular body, this point is C and this point is D. Now a tangential force is applied on the upper surface. Here the lower surface or base of this block or rectangular body is fixed. If a tangential force is applied on the upper surface of this body, the shape of the body will be changed. Now this is the changed shape. Here C point is moved at C prime point, that is C to C prime point. Now the new position of C is G prime, and here D point, and an angle is produced here. This is the original position, and now this position, that is the body is twisted at an angle theta. This angle is known as shearing angle or shearing strain. The relative displacement of two planes situated at unit distance is the shearing strain. That is, here relative displacement is C, C prime. Original position is C and new position is C prime. Therefore, relative displacement, here lower surface or base is here and upper surface is displaced, and the amount of displacement is C, C prime. That is relative displacement C, C prime. Relative displacement of two planes situated at unit distance, that is relative displacement per unit distance between two planes. Here distance between two planes and distance between upper surface and lower surface is CD. Therefore, shearing strain is equal to C, C prime divided by CD. C, C prime is the relative displacement and CD is the distance between two surfaces, CD. But C, C prime by CD is equal to tan theta. Here C, C prime divided by CD is equal to tan theta, because here C, C prime, that is perpendicular, and here CD is base. Therefore, C, C prime divided by CD is equal to tan theta. Here, as the angle of shear is small, this theta angle is very small. The shearing strain theta, here theta is measured in radian. Theta is very small, therefore we can write theta radian is equal to tan theta. This is equal to C, C prime divided by CD. That is, shearing strain theta is equal to C, C prime divided by CD. Now, shearing stress. For resisting the shearing strain, the restoring force produced per unit area and perpendicular to the surface is called shearing stress. Shearing stress is equal to force F divided by area A. Here F force is the tangential force acting on this surface area A. Therefore, shearing stress is equal to F divided by A.